This Cisco C1861 just might be the telephony home labber's dream router. It's got plenty of analog ports on board, a bunch of power over Ethernet ports for IP phones, but they hardly ever come with power cables. So we're going to put this thing through its paces. Build a power cable, get some phones hooked up to it, try some SIP trunking with an existing IP phone setup that's running in my retro rack. Oh, we got this direction. We got this direction. I want to see if this Cisco 1861 is really the all-in-one telephony home lab router I'm hoping it is. Let's get into it. This unassuming little device is a Cisco C1861 router, and it just might be the ultimate all-in-one VoIP and analog telephony home lab device. I first caught wind of this thing at VCF Midwest in September of 2025, and I was talking with Danny. I think he had one, or he was showing it to me, and I knew right away something special going on here. In fact, I bought one, $40 shipped to my house, probably the Sunday as I was flying out home from Chicago. It's got many compelling factors, but let's start with the one that I think is the most compelling. It's got 4 FXS ports built in. FXS is fancy telephony speak for you can plug an analog phone into this and it'll give you dial tone. And with 4 analog ports, if you want to stick with good old POTS, you can get pretty far. You could slap a phone in here and make it when you dial a number, it calls a phone over here and vice versa, and configure these to your heart's content. This was marketed as a branch office router, sort of an all-in-one deal, which makes it very interesting. Well, let me show you why it is so cool that those FXS ports are built in. Let's say you want to start diving into telephony in your home lab, whether it's for dial-up networking for computers, you want to do VoIP, you want to get some phones on there, or whatever. You do your research and you land on a Cisco router that you like. In this case, we've got this very nice 2900 series. I think it's a 2921. Pretty cool looking. Very powerful. Plenty of modularity. You've got 4 HWIC ports here. You've got a big old modular port here. But you've done your research. You know you need an FXS HWIC card to pop in here. You've sifted through all the Cisco documentation and wrapped your head around the 300 iterations of these WIC cards they made, and you know you need this one. So you're feeling good. You pop in the VIC-3 4-port FXS card. You're so close to hearing that dial tone on an analog telephone. You can taste it. You power it on. You get a phone plugged in. After the router's all booted up, you notice those lights never turn off. And you never get any dial tone. With a default configuration, you slap a new FXS card in, it should at least give you dial tone, even if you can't dial anywhere. You see those lights labeled PVDM 0 and 1, and the fact that they're off? That stands for Packet Voice Digital Signal Processor Module. You're going to need to buy some of those to do any phone stuff with this thing. This particular router series is meant to have expansions inserted inside, as you'll see. So it is very easy to take the lid off. Just like that. Down in there, 2 PVDM slots, 0 and 1. Kind of look like RAM slots. You're going to need to buy 1 or more of these. They let you do VoIP and analog telephone voice calls. Each PVDM gives you a certain amount of voice calls you can perform. This one says PVDM M364. I don't know off the top of my head, but that might let you do 64 voice calls. This one says PVDM 316, so maybe that's why the one that handles less calls doesn't have a heat sink or something. I'm not sure. I basically do like 1 voice call on this thing, so I'm a little over provisioned. Let's see if we have better luck now. This time, both PVDM slots are showing a green light, and the light's turned off here. When I pick up the phone, we get the active green light right there, and we have a dial tone. Now, I'm not saying going this route is impossible, or even all that expensive if you're careful on eBay. I'm just saying it's a little involved, and some routers can't even do voice stuff, and how you approach and need to tackle the voice problem from a hardware perspective depends on the router series. For example, this big Cisco 3700 series, you don't open this up and put PVDM sticks inside. And you can't just slap your FXS cards in here because it doesn't have native voice capabilities. You have to buy a big module similar to this one, slot it in one of these, figure out the right FXS card, and slot it into a voice capable, parent module or whatever you want to call it. The point is, they're all a little different and you have to do a bunch of research to figure out what you need. Theoretically, we're not going to have that problem with this thing. Because they shipped it with the 4 FXS ports on board, presumably it's got a PVDM or DSP chip of some type inside. We'll open it up, see if we can find it. That, I think, is the most compelling aspect, but there's more. It's also got 8 power over Ethernet capable ports. So it's a router and a switch. The PoE is important for telephony because with the right version of iOS on here, you can do VoIP stuff and power the phones directly. So this 7965 Cisco IP phone, I'm fairly certain takes normal PoE, so this thing could power it. These phones are getting cheaper and cheaper. They're getting e-wasted every day. You can find good deals on these. The trickier part is running them, and this thing might help with that. Also, as a bonus, check out this 3.5mm jack. You can feed audio into this for music on hold. So theoretically, there's some way to set up the Cisco call manager stuff with music on hold. You can pipe it in over this jack they've got right on the front of the unit. Those things are most important in my book, but we got another honorable mention. It's got an HWIC port, the one piece of expandability that this thing supports. Mine happened to come with this cute little two-port serial port deal for connecting to some like old CSU DSUs or maybe to other routers. A lot of the listings on eBay I saw for these had this port in it, so that must have been a common config for whatever reason. Let's take this out. And to really do some telephone home lab stuff, you can go pick yourself up an HWIC T1 CSU DSU. With other gear, you could accomplish the same thing with that card I just took out, but I think this is definitely more up my alley anyway when it comes to home telephone stuff. So you could, trunk a T1 line in here. I don't actually know if it's compatible. I didn't look up the Cisco blessed theoretical matrix of what works in here, but we'll try it out. Leave that in, see if we can power it up. Let's talk about price. So you saw I paid 40 bucks shipped to my house. I'm seeing 30 bucks, 40 bucks, 50 bucks online on eBay right now in March of 2025. Before you get pitchforks out and say I'm driving prices up, I don't think I have as much influence as you think I do. There's of course the jokers selling these for hundreds and hundreds of dollars on eBay too. Don't buy those. But there's a pretty big problem. This thing was too good to be true. The affordable ones never come with a power cord. And this is what the power jack looks like. You aren't going to have one of these sitting around. Now I knew this power supply issue was going to be a problem when I bought this thing. So I was like zooming in on pictures of it the whole flight home after I bought it, trying to get a closer look at that connector. The good news is it's just 12 volts. 10 amps is a little intense, but that would probably be with the full PoE bank fully loaded or something. That's my best guess there. And then I realized that connector looks awfully familiar. It's basically a PCI Express power connector. Just trying a bunch of different cables I've got here. And the first 3 out of 4 pins will fit perfectly, in fact. No adaptation even required for this one. I think the other portion that goes on the CPU or the power supply does not fit. It's not quite right. A typical PCI Express power connector will have this kind of bonus set of pins on the side, and it's kind of funny how Cisco did this. So these will fit in just fine there. My particular clip is getting in the way. Let's solve that problem. Well, I can't find any clippers, but you'll have to believe me, if I was to clip that off, it would fit in there just fine. The other one I was showing you happens to clear it and actually clips in properly. It's just the luck of how these particular cables were made. Typically a PCI Express adapter has this extra kind of sidecar deal that you can clip on, and that is what is going on here. I think this one fits in like that, so theoretically if I was to clip that you could get the whole complement. I don't even think we need that though, so what we're going to do is hopefully we can just use this one, and hopefully those 2 far right pins are just grounds and they're all connected to the other grounds. You'll notice there's only 2 colors on these cables, yellow 12 volts and black for ground. So let's open this thing up and see what all these pins are, see if it's a pin match. I suspect it is because by pure coincidence, someone in the Serial Port Discord was doing this exact thing right when I was thinking about it in September. So I'm feeling pretty good about this project. I have not read the manual yet in true me fashion, so I don't know if there's serviceable parts inside, but they certainly are not making it hard to get into. Wouldn't that be funny if I gave you that whole PVDM spiel and this thing's like missing one or something? That would just be perfect, wouldn't it? Looks like 4 screws is all that's holding mine together. I've been messing around with it. Doesn't want to come apart. It's looking like maybe we have to take this faceplate off. So I'm going to pull out the HWIC card because I don't think it's going to clear very nicely with that sitting in there. And then it looks like maybe it's as simple as letting these loose. This is a very flexible plastic. I would really be mad if I broke this thing. Might as well break it on camera so you can all get mad at me. Okay, that comes off. I still don't know if I needed to do that. There's a secret second HWIC port behind the faceplate. I wonder if they use the same chassis for different configurations. It was necessary to take the faceplate off. There was a screw right here that I had to take out, which was hidden by the faceplate, and it's got these lovely little plastic nubs that are only going to withstand so many of these adventures. Sort of tempted to leave that out in case I need to do this again, and then I could leave the faceplate off, but this slides just fine. That is a full-blown second HWIC port that they just hide from you. Maybe you could put like some sort of VPN security module in there or something. And then we do have a PVDM. Right there, we've got a PVDM 2-32, so this thing can handle 32 voice calls, I believe. The key here, though, is that this thing would have shipped with this thing, I believe. I'm pretty sure standard, these were all shipping with a PVDM inside of it, so if you pick one up, unless it's been pilfered, which is totally possible, you should be okay, I think. Here is our power connector, and all 8 pins are going into the board. And so the idea here is I'm going to figure out which ones are ground. That'll be easy. And then presumably the rest are 12 volts, so we don't have to worry about that. There's only one voltage coming into this thing. So the idea here is I've got the voltmeter set to beep when we have some continuity, and I'm going to find all the grounds. They should all be grounded to the chassis. Okay. So the top 4 are all ground. I think that's good though. That's exactly what we want. So you can see the top 3 pins there are all ground, which means so far we line up. Now on the connector, I'm able to get in like this. I'm missing these 2 pins here. But if they're both ground, I know that one's ground. I already have a bunch of ground coming in, so I shouldn't even need to use that. I mean, maybe there's situations in which you do, but so we know that one's ground. Is this one ground? It's not. That is presumably 12 volts. Okay. Also 12 volts. 12 volts and 12 volts. Which again, totally fine so far. The top of one of these connectors is all ground, and the bottom, they're all 12 volts. So remember, I can't really plug these 2 pins in easily. This one's ground, because it's connected. All these are ground. But if the 12 volt rail is connected, I don't need it either. It's not. Okay, we might have to figure that out then. That's connected. That's connected. So those 3 12 volts are connected. This one is not. It's on a different rail. That's odd. Let's see if it's actually used. Been trying to figure out if this 12 volt down here goes anywhere. So I'm trying to trace it, and I can't find it connected to anything. I also can't see the traces, unfortunately. It's such a modern, dense board. But if I go to this 12 volt down here, I can see it all over the place. It's there, it's there, it's on this little board down here, passing to the lower board through this little doddering system. To summarize, the ground that's a pain to connect to is connected to all the other grounds, so I'm not worried about it. Down here, I guess I keep calling this 12 volts. I don't actually know what it should be. It doesn't appear to go anywhere, so I'm also not going to worry about it. The 6 pins on the left are what we care about. 3 grounds on the top, 3 12 volts on the bottom. This board is really weird. All sorts of secrets. So we got this other HWIC over here that you can't see with the front plate on. Over in here, what looks like another sort of expansion unit, unpopulated. There's another one of those way down under the power supply, also unpopulated. You can just barely see the clips sticking out. There's maybe a better view of that guy. Then on the side we've got another mystery. Little compact flash slot. This is not the one on the front that we're going to actually have to populate. Let me see if I can get this thing out. It's not going to be easy. Oh God, I made it worse. Don't worry, I'm a professional. Oh yeah. No, don't go back in. We got it, boys. No. Ah, yes. I mean, I had a feeling that's what it was. This must be the firmware, I guess. Firmware might not be the right word. A last-ditch copy of iOS and any software this thing needs if you totally hose your own installation, maybe. Or I'm overthinking this, and this is just the internal 1 gig storage, which makes this thing even more of a bargain, because if that's the case, you might not even need to buy your own flash cart for the front. We will find out if I can power this thing on. Digging through all my power stuff, and I think the best bet is to use the bench power supply. You could maybe longer term wire up like a Pico PSU, or better yet, you could probably get like a barrel jack to wires and figure something out there. Maybe that's where we'll end up actually, and I'll just heat shrink the whole thing. But for now, this is the one I'm going to use. I don't remember where this is from. Maybe a Dell server or something. You can buy all these adapters online. And it's not a perfect PCI Express. I haven't been explaining this very well, but PCI Express looks like that. At least mine does. And it wants these other 2 wires to be on the opposite side that PCI Express usually has them on. That's why I kept saying they're hard to deal with, so we're not even going to use it. But I want to plug this in like that, grounds on top, 12 volt on the bottom. We're going to hope that the other 2 pins aren't going to matter in this case. And then I could just snip this off, but I think I'm going to try to cut these pins out. I don't have the right tool to remove them properly, just so it's easier to get some probes on there. So I'm going to do that real quick. This is going about as well as you think it might, but as you can see, I'm able to get the pins out. At the low price of shooting this plastic all over the place, and often right into my face. I have no idea why I decided to do it that way. It's not like I care about these pins, but it's done. And I only mangled one. So what we're going to do is kind of hold at least a few of them together, and we'll alligator clip on. This is like some pro level stuff. We can plug this in to the bench power supply. Obviously, this is not the permanent solution. I just want to see if this is going to work at all. I really need a better bench power supply. That's why you never see me use it. For some reason, I cannot set a fixed voltage without a load, and I'd rather not ramp this thing up to some amount of volts. That's kind of annoying. Old faithful, the Wii for me. Back at it again, saving the day. Okay, so here's the plan. Got this little barrel jack adapter, and that should be ground. That should be 12 volts, 11.8, close enough for me. Okay, thank you for your service. The Wii for me remembers its last voltage setting, as I recall. Yes, it does. See if I did this right. I did. I can't think of anything that could possibly go wrong. I double checked that the top is ground. I also double checked that these black wires on this end are actually the black wires over here. I've got a console cable plugged in. The power supply is ready. This is just the way it is. I'll keep an eye on it, make sure they don't touch. First boot, I got the console open. Oh yeah! Right to life. Fan looks good. Look at that, right on the console. Yes! I love it. Oh yeah, this baby is alive. It's in Raman because there's nothing on the flash. Ooh, this is exciting. Got a real light party going on down in there. This isn't terrible. It's blowing a lot of air. I think it's a variable speed fan. It kind of revved up and down as I booted the thing. Yeah, it's moving a ton of air. Noxua mod opportunity, perhaps. I suspect with the case on and booted into iOS, it might rev that thing down. So we'll see, but this is really good. Okay, this thing's healthy. We can power it like this, but I'm gonna cook up a slightly more permanent way. I'll let you know what I come up with. I'm pretty sure the slightly more permanent way is I'm gonna clip all these off. Again, don't know why I went through all the trouble breaking that connector off. I'll bind them all together, and then I'll probably screw them into this, and maybe we'll throw some heat shrink over it or something. Okay, so these all wound together. It's just too big to fit safely, cleanly in my barrel jack connector here. So I'm soldering on a single thinner wire. We won't be running 10 amps through this. This isn't even the final setup I want. This is just so I can use this without knocking into it and shorting. So we'll let the iron heat up and solder those together for good measure. I am not very good at this, by the way. My strategy is to pour solder into it. It's kind of working. Oh, and if you don't like how I pronounce the word solder, I will direct you to my fish friend here. First thing we'll do is heat shrink those 2 points I just did. Close this side up. Alright, then I think I'm going to heat shrink on top of the heat shrink. Maybe just like that. Alright. So here's the finished product for now anyway. I probably could clip off the stuff I'm not using over here, but that's fine. Goes into the barrel jack, soldered together the wires, and did some nice heat shrink. Now I had all this stuff lying around, so it's kind of free I guess, but I don't think it would cost that much to whip something like this up. Double check the polarity and everything and that my wiring was good. But before we close the lid and configure this thing fully, or figure out if we need to get iOS on it, let's boot it back up one more time. I want to see what the story is with this internal flash card. Didn't look like there was a version of iOS on it, but maybe, I don't think I've ever tried it this way, but maybe we could pop it out, put it in the Windows 11 machine, and drag one over instead of doing the whole TFTP network dance. So I'll boot this thing back up. Right to life. There's that variable fan I was talking about. Now it's all kicked back on. This thing at least gets to ROM on very quickly, so trying to remember what we can do here. Dir flash, something like that. Dir. There's a way to list all, oh, there it is. Dev for all the devices. Okay. Dir flash. Uh-oh. So the internal one might not actually be usable. Got this 1 gig compact flash card. Let's slide this in, reset the button there, and see if dir flash is that thing. I'll do a dir flash. Okay, at least it thinks it's there. Let's restart the machine. This is real time. Look how fast this thing is. So, couple options. I think this flash card needs to be formatted. Let's just try it in a Windows 11 machine. See what happens. Finally found my USB to compact flash card adapter. Obviously, I've never used it. But in the spirit of not having to buy more crap to use this thing, let's try something else. So I'm pretty sure the reason this thing is complaining and it can't open this flash card is it's not formatted in a way this thing understands. I opened this right out of the package right before I popped it in there. Pretty sure iOS wants FAT16 or FAT32 and an MBR, and we should be able to accomplish that with Windows. But you're already gonna have to buy like a power cable situation, and we're eating into the cost savings here. So let's try to boot a version of iOS into this thing's RAM with ROM on over a network and format the card that way. Let's get this thing on a network. That is the fast Ethernet port. I have to keep referencing the panel, so obviously nothing's labeled. On a TFTP server, which will be available on the network I just plugged that thing into, I've got a copy of iOS. This is where you're going to have to do your own research. I don't have any moral qualms. This is an end-of-life product. Cisco wouldn't sell you this if you begged them to. But you're going to have to do your own research on finding iOS. They're out there. This thing's got an IP address of 10.0.0.102 on this network. Remember that number. We will be doing what every Cisco iOS admin has had to do in the past, probably under duress. Disaster recovery with TFTP download. Basically, in ROMmon, we're going to be able to give this thing an IP address, a subnet, the gateway. We'll tell it where my TFTP server is, and a file. Now, normally, you can use this tool called TFTP download. In fact, if we issue help on the C1861 over there, we can see we have that TFTP download tool. This will download an iOS bin off the network and put it on a flash card. But we can't read our flash card, as you saw before. It knows it's there, but it's having trouble opening it because it's not formatted, and we can't format it with this very basic ROMmon. But you can pass it -R. This will load the iOS, into RAM and not even try to write it to the flash card. It'll be in memory on the device, and we'll actually be able to get into iOS, if this works, and format the card from there. That's my theory anyway, so let's find out. We're basically gonna do this. We're gonna issue the TFTP download R, give it all the information, and say continue. Let's find out what happens. TFTP download R. It wants me to set them first. Variable name equals value. We'll give this an IP address of 150, the correct subnet mask, the gateway, and as you'll recall, my TFTP server is at 102, and this is the file name. So let's try the download again. Is it going to work? So I've seen this have trouble in the past, and there are some flags you can set to get some more verbose logging, but we'll see what happens here. I think the dots at the bottom mean it's failing. Can't remember. There we go. We're cruising. So it is downloading that image from my TFTP server. Now, you can find all sorts of tutorials online, blog posts for every single operating system under the sun, how to set up a TFTP server on your network. It's relatively straightforward, and hopefully you already have a computer, so shouldn't cost you any money. I'm getting a little ahead of myself because I don't know if this is going to work, but this thing was only like 17 megabytes, so it shouldn't take terribly long to transfer it over. It's loading it. So now, I think what's happening is it's got the bin and it's booting into it. I don't know if it's just going to load it up into RAM and we got to issue a reset, or if it goes right in. I'm not really sure. Seems to me like it's jumping right in. Sees all of the equipment. That's exciting. I think this cannot open device is the flash card it's complaining about. I've used these exact flash cards. They're just no-name whatevers from Amazon. Uh-oh. Ooh. Now that it's in iOS, the fans rev down to near nothing. I was right. It is so much quieter in here. Let me show you. No noise canceling or anything. You heard how loud it was earlier. Listen to this. Barely making any noise. That was no noise canceling, and I'm pretty sure the noise is just this fan's pretty old. Okay, so we're gonna get in here. Invalid DOS media or no media in slot. Let's try formatting flash like that. Can't wait to get rid of that annoying thing. Format flash, confirm, yes. Okay, now we're actually gonna sort of do this whole thing over again. So, as you can see, I can't remember. I've turned this off before. I can't remember how to do it. Directory of flash, no files in directory. So we've loaded iOS up into RAM, but we need to get it back on the flash cart. So we're basically going to do the whole thing over again. We're going to set up the IP address again. I think I called it 150. No shut. All I did was basically set up that interface I plugged the red cable into with an IP again. I realize I'm kind of like whirlwinding this here. Let's see if we can see my TFTP server, and we can. So the way we do this is we say copy from TFTP to the flash, and we'll give it all the information again. And we are re-downloading it, but this time it's going on the flash card. Hopefully this makes sense. Pretty sure this TFTP stuff is something Cisco calls auto-config. So all the configuration you make on these Cisco devices get written out to configuration files, obviously. This one doesn't have one because there was nowhere to put it. And so when iOS kicked in, it's panicking, I think, and trying to reach out on the network and find what it should do. I wonder if it'll go away if we just write a config out. I don't know. At any rate, let's take a look at what we've got in our flash. And we have our bin, and we want to tell the thing to boot from that next time. So I think that's boot system flash. I can't remember the syntax. Is it like this? That might be it. There it is. Now it's going to try to boot from that next time. Let's write this out. I know this is a little quick, but now let's power cycle it and see if we get into iOS successfully. All right. I think we can actually put the lid back on. That's pretty exciting. It's pretty straightforward. I don't think I caught myself taking it out on camera, but this is the screw that requires you to take the faceplate off. You could probably leave it off, leave it out, I should say, so that you don't have to mess with this faceplate too many times, but hopefully I never go back in here. Back looking the way it's supposed to. Let's get the T1 card in there. We're not going to do any T1 stuff. Just want to see if it recognizes it. Okay. So you can see pretty loud at first. When it boots into iOS, it probably has temperature sensors or something. It revs way down like I was just showing you. Loading right into iOS, I made no other configuration changes other than what you saw. It skipped ROM-mon, and we're booting. I don't think it sees the T1 card though. It sees it, but doesn't work. So it says CSU DSU WAN daughter card, which is what it is. Module not supported or disabled in this slot. Well, no router's perfect, I guess. This thing is working. It has a power cord. It boots. It has iOS. Let's see if it can do some phone stuff. So the most basic kind of telephone setup in a home lab you're going to want is being able to dial between two analog phones, at least in my experience. And they could also be modems on either end. You could have computers dialing terminals and everything. Notice how all the ports on here have labels. This one says 0/0. This one says 0/1. We're concerned with this FXS card. And so if we want to direct a configuration for this port, it would be 0/0/0. This will be 0/01, 002, and 003. So keep that in mind as I'm setting up the configuration here. We'll set up some basic what are called dial plans to let us dial a phone in port 0. And of course, you need another phone to do that. So we'll also have a phone in port 1. I'll be able to dial this phone from here and this phone from here. Let's set that up. The router's powered up. I've made no configuration changes. Something to note is that by default, if your FXS card is working, it will provide dial tone. Dialing won't accomplish anything without the configuration I'll show you, but we do have dial tone, so that's probably the first thing to check. We're going to create what are called dial peers. So I'm going to get into enable privilege mode, privilege exec mode, and I'm going to configure from terminal, and I'm going to type, I haven't memorized this, I'm looking at it. It's pretty simple though. So I'm going to set up a dial peer, and it's voice, and you give it an arbitrary number. So I'll say 100, and it's a POTS line. We're configuring the dial peer. You give it destination pattern, and I'm going to use 500. So whenever anyone dials 500, this dial peer is going to kick in. And we assign it a port. So remember I was saying 0000001, this very first port, when anyone dials 500, it's going to ring that port. We're going to set up another one for the other phone, destination pattern, let's say 600, and that will be port 001. So when anyone dials the number 600, they don't have to be full telephone numbers. You can make them the full length if you wish. It'll dial that port. Let's see what we get. This guy is plugged into port 1. This guy is plugged into port 0. If I dial the number 600, it should ring this guy. And it does. And we have a call. There you go. HomeLab telephone provider. But that's pretty boring once you've done it a bunch of times. Let's kick it up a notch. I've got this Cisco IP phone. And notice what happens when I plug it in to my RetroRack network. It gets power. And we're going to boot up here in a second. It's going off on the network and finding all its settings. This has been configured in the RetroRack as the number 102. So what we're going to attempt, and I've never done this before, is something called SIP trunking. We are going to teach this router that when I dial a number that starts with 1, it should go off on the network to another router and try to talk to it. Conversely, I'm going to configure the router that this is hooked up with. When I try to dial 500 or 600, go out on the network and find this guy to ring one of these phones. Let's figure that out. This isn't going to make a whole lot of sense unless I give you a quick lay of the land here. This is the RetroRack network. It is 10.0.0.0, and the router we've been configuring is ultimately plugged into one of these switch ports. So they're all on the same network, but the phones aren't going to know how to talk to each other without a bunch of configuration. Speaking of phones, my main telephony HomeLab setup is this Cisco 2800 series router. It does VoIP and analog phones. It's got a bunch of cards on the back for the FXS ports and all that stuff. And so that phone I was plugging in connects up to this and can make VoIP calls through this router. All my Cisco IP phones get their power through this Catalyst 3500 Series XL inline power delivering switch here. Got a couple of them scattered around. This guy has finished its little boot process, and of course, right away, it doesn't know a number that starts with 5 and gets real mad. I can call that other phone in the other room. I think it was a 1. Yeah, it's ringing. Can sort of hear it in the other room. Our goal today is I'm going to pick up this phone, which is connected to that 2800 in the RetroRack, dial a 500, maybe a 600. This ringer sucks. Maybe we'll dial 600, and we should be able to talk to this guy. And we're going to accomplish this with something called SIP, Session Initiation Protocol. And we're going to do something called SIP trunking. Basically, it lets voice travel over the internet or a network. And we're going to trunk this router and the other one together so that when you call a number that the other one knows about, this one hands it off. We'll see. I've never done it before. Been reading a bunch of articles about SIP trunking. I think this is the basic idea. I have 2 routers. I'm going to teach the routers about each other with dial peers. And then we might have to bind something, I think it was called the SIP service or something, to the interface. Let's start with the dial peers. Here is the router in the RetroRack, and you can see when I plugged in that IP phone, it logged that it knows who that is. So let's get in here. Actually, let me show you how it's configured today. So I've got a couple dial peers on this. When you dial the number 200, it hits an FXS port, and here's the VoIP stuff. So whenever you dial the number 10 something, all my VoIP phones, it hits the call manager running on this machine. This router is 10.0.0.6. So we're going to set up one for dial peer voice 600 pots. I think that's what we want. So let's do that. I'll just call it 600 pots. Kind of funny. So I'm going to hard code a destination pattern of the number 600. And then we're going to try session protocol. And let's see what options we have. Oh, it doesn't like that. Let me go read the PDF again. I don't know. I was hoping to set up the session protocol as SIP, but we'll see what happens. I can set the target to the other router. More research. I think I know what was going on. I was trying to set up a pot style peer, but this remote router, it's going to be VoIP to get to the router in here. So I think what I want to do is VoIP. Yes. Now, do we have more session options? We do. And we can take a look at the protocols, and we want to do SIP v2. And we're going to give it a session target of the router that is sitting next to me in this room. I believe you do want to specify a codec, how it's going to encapsulate and transport the voice. We won't worry about that too much. Another important thing would probably be to give it a pattern. Okay, let's see what I just created. Sorry, we're doing this live together. I have created this dial peer. I happen to match these numbers. You don't need to. Whenever someone dials 600, it's going to hit this dial peer, and it's going to try to talk over SIP to the router sitting next to me. I saw in the documentation something about needing to bind SIP to the interface, but we're not going to worry about that unless we have to. Let's hop over and do the opposite on this router. So here's the router that's in the room. Hopefully this is making sense. Let's take a look at what it's got going on. Should be quite a bit less. Here's my dial peers locally for this router. So you dial the number 500 or 600 and it knows what to do about that. So we're going to do the same thing over here. We'll do a dial peer voice. Let's call it, I don't know, 300. Probably a method to not losing complete track of what you're doing. So we're going to give it a destination pattern of any number starting with 1. I believe that's what that does. And we can do a session protocol SIP v2. And of course, we're going to target the retro rack router. Okay, I like to look at what I've just done every time, just to keep it straight in my head. So now, if I dial a number that starts with 1, it's going to go over SIP and talk to that other router. What? Place your bets. Is this going to work right away? I'm going to be shocked and very happy if this works. So I'm going to try to dial 102. I have dial tone. Yeah, not ringing, nothing. Debugging time. Well, just for fun, actually. Let's dial 600. Oh, we got this direction. We got this direction. Okay, this is huge. This is massive progress. This is crazy, crazy progress. Oh, we got to do that again. Yes. Okay, one direction of our SIP trunk is working. I can dial from the retro rack over my network on SIP, and then it can dial this analog phone from this router. Yeah, okay. Let me see if I can get the other direction working. I'm looking at the retro rack configuration here, and I had previously set up this dial peer for my existing VoIP setup. And when you dial any number that starts with 10, it hits this router. And I had set up this destination pattern a little differently on this local machine. I think it was just a 1. Let's try identical destination patterns. So here, this is the local router config. You can see I have a 1. Let's get in here. Oops. Let's get in here and change that. And we're going to do destination pattern 10. Who knows? Let's try it. Let's see. No. I gotta do this again though. Whew. That's like too good. I was on the right track. I got it working. So previously, this is the router in the room with me. I had set destination pattern 10 ... This is actually expecting 4 total numbers, so like 1002. I want to dial 102. So I changed it to destination pattern 10 and then a single dot. I'm not sure how my 2-dot deal is working on the other router, because I can call, all my phones are like 101, 102, 103, and on the existing retro rack router, they can all call each other fine. It's working now. Check this out. One missed call from my previous test just now. Here we go. 1, 0, 2. And just like that, it works. Kind of love it. Now, if Mark and Ben from the Serial Port are watching, they're probably like, hey dude, you'll sip in your basement, but you won't sip to us. If you subscribe to their Patreon, one of the tiers at least, gets you access to a service they have that lets you dial into one of their SIP numbers. I'm just practicing, guys. We'll do a whole video where we get our stuff connected. So if you're putting the pieces together, if you buy one of these and your buddy buys one of these, or equipment that can do equivalent stuff, you can call each other on your analog phones over the internet. I do want to try one more brief test though. This is a slightly, maybe not newer, but more endowed version of the IP phone I was just showing you. This is a 7965. It's got a color screen, and this wants, I think, power over Ethernet. So you'll remember the front of this 1861 has PoE jacks, but I mentioned over in the retro rack, my switch there does something called inline power. Inline power was Cisco's proprietary precursor to standardized PoE, and this older phone uses inline power, and as I recall, this one does not. Let's double check my thinking here. So we'll get this one unplugged, and I'm 99% sure if we plug this one in, nothing's going to happen. Correct, because this is not actually PoE. This is something Cisco made called inline power. But if we plug this one over here in, bam, right away, it is powering up. So this guy, obviously, is delivering PoE, Java mentioned. And so you could get a whole VoIP setup going with phones that take normal PoE on this thing. I will leave that as an exercise to the viewer because I've already done that. I have a big old video where I set up my existing VoIP setup, but you could do, you know, IP phones over SIP to other IP phones, no problem. This thing's capable of handling the IP phone stuff. So what do you think? This seems like a pretty primo all-in-one sort of retro router. It's from the mid-2000s. It does VoIP. It's got built-in FXS ports. I think that's the primo killer feature. And if you can get one for cheap, I would say 50 bucks or less, and you feel like you can do the power supply, you know, the make your own power cord thing, it seems like a pretty good option. If I had gotten this maybe 2 years ago, I think I would have held off on dealing with a bunch of other Cisco gear because this would have done everything I ever needed. Now, I know myself, I eventually would have gotten bigger gear. I like bigger gear. I like rack mounting it. If you're really lucky, there is a rack mount kit for this thing. Kind of comes off the side, lets you mount it up in a rack, of course, but maybe you'll find that in a dumpster somewhere. I have to imagine they made a lot of these things. So yeah, be on the lookout if this is something that interests you. It's definitely better than dealing with an ATA. I find that these FXS cards in Cisco routers basically deliver really clean analog lines, and I've never had any trouble in that regard. Hopefully this was useful for you. It was useful for me to refresh my memory on all the dial pierce stuff, and we learned how to SIP trunk, which was surprisingly easy. I'd never actually done that before. There will be more SIP trunking in the future on this channel. I think that'll do it for the Cisco C1861. Really nice little router. All, you know, just like everything you need, compact in one little package. Barely makes any noise. I'm pretty impressed with this thing. This was a quick little foray I wanted to do. Lots more videos coming in the future on all sorts of stuff. We are on the road to 100,000 subscribers this year. So if you haven't subscribed already, please consider doing so. It really helps the channel grow, helps me feel good about making videos, I guess. And of course, if you'd really like to support the channel, I'm on Patreon. I post behind the scenes type videos, early release, what I'm tinkering with, and you get access to the Serial Port Discord, where I hang out all the time. Speaking of the Serial Port Discord, I need to give Pitor a shout out for giving me the additional confidence to tackle this project. By sheer coincidence, they set up their 1861 with a PCI power supply right as I was literally buying mine and researching. It's so funny. It seems like all of us are on the same wavelength and you just kind of end up doing the same thing without even talking to each other. So huge shout out to them. I hope you enjoyed this video. I had a lot of fun making it. I'll catch you in the next one.